Good morning, and thank you for joining us today for this Techinar highlighting the SD Core version 1.2 release. Before we begin, just a few things. First, all participants have been placed on mute. We do invite you to ask questions using the Q&A module at the bottom of your screen. Simply type in your message, and following AJ's presentation, he will go through the questions and answer them. AJ, please take it away.
Thank you, Dennis. Hi, everyone. My name is Ajay. I lead SD Core team within Ether project. Today, we'll see what are the various features we have delivered in SD Core 1.2 release, and as well as we will see some glimpse of the what's next we are working on. And thank you for joining this webinar at this time. Yeah, agenda is very simple, so I'll just give the overview for 1.2 release. For those who are probably attending it first time, there's one slide around the SD Core introduction, which talks about the current supported features in the 1.1 release of the SD Core. And then we will go in depth about understanding the 1.2 features. At the end, I'll go through all the questions and answer it on the air. Okay, so so we released SD Core 1.2 on October 11, 2022. The focus of this release is like making the changes in the 5G core to make it cloud native, right? So we'll see in more details what exactly we have done. So release blog, we have it available on the ONF website. The link is provided here. We have release notes for 1.2 release. That's also link is provided here. Helm charts for the release are available in the charts repository. And we have tagged Helm chart code for the 1.2 release, and as well as branch is created. So it's easy for anyone to just take it from that tag. We have updated the SD code document for the 1.2 release. And in the website now you can see that there's 1.2 tag. So if you want to stick to only 1.2 release related document, you can use that specific branch only. We don't tag SD core code as such, but we do have the commit hash available in the image name. So that will help you into creating the branches if you want to do any changes, right? So, and last but not least, I should say thank you for all the community members who have contributed to SD Core 1.2 release, namely Intel members from the Intel, Infosys, CPQD, Purdue University, and GS Lab. And there are many more individual members who have contributed to Ether project with the individual CLA, right? So thank you to all of them. Yeah. Now, this one slide will just give a recap of what we support in the SD core. So SD core is like 4G, 5G, and 5G NSA. It supports these three types of configurations. 4G we support release 13, and 5G we support release 15.3. SD core is fully containerized, and you can use Helm charts to deploy it on the Kubernetes. Like it's very simple. We have provided enough documentation, and we continuously improve the documentation as we get feedback from the various community members, and that really helps. The architecture is CUPS compliant. So for this CUPS compliant is mainly applicable for 4G, 5G is anyway, it's CUPS compliant from the standard point of view. We have two UPF implementation available, base UPF and P4 UPF. If you have your own UPF, you can always use the SD core's control plane and connect it to any other UPF, which is compliant with the 3GPP release. You may have some hiccups. I mean, I have seen a couple of members trying to use their own UPF. There were some hiccups in terms of configuration or the release version mismatch, but those things are very minor issues and can be always resolved very easily. Base UPF is a software-based UPF, and it's available in the two mode, AF packet mode and DPDK mode. So DPDK mode comes with more configuration. You may have more things to do in terms of configuring the worker nodes in the Kubernetes. AF packet mode is very easy, and that's what typically we use in the Ether in a box. The differentiating factor of SD core with the any other core network available in the open source is that we have given the APIs to create and update and delete the network slice. So aim is to make things very simple for the user who doesn't understand the 3GPP complexity, and they should just need to understand few APIs about how network slices can be managed. And at the same time, we have the second set of APIs, which is about the provisioning the subscribers in the SD core. So it's about adding the subscribers in the UDR or UDM in case of 5G, and adding the subscribers in the HSS in case of 4G. And there is a way how you can do that through the config map, or if you want, you can do it through the REST APIs. The API documentation is updated, and you are encouraged to see the new documentation and give us the feedback. There are 3 levels of QoS which we have tested, which is like first is a slice level QoS. So this really makes it easy to control how much QoS bandwidth is assigned to given a slice. Then we have UE level QoS, and the third is the application level QoS. So all these 3 things are configurable. Currently, we are in progress of QoS scheduling support. Community members are working on it. This feature could not make it to release 1.2, but it will be part of 1.3 release. We do support application filtering. That's like a classic use case for the private 5G, where you want to restrict the users accessing specific application based on what slice they belong to. And last one is access control. That means any unauthorized user shouldn't be able to access the core 5G core. And that's the, so this is very high level support which exists in the 1.1 release. Now let's jump on like what we have done in the release 1.2, right? So one of the goal when we started on working on this release was how do we give the truly cloud native support in the SD core, right? So we started with having multiple instances for all the network functions, but there's a lot of work to be done, right? So currently what we have achieved is that multiple instances of AMF and SMF. I'll go through it, like what exactly we have done to achieve that. And while we bring in the multiple AMF and SMF in picture, there were few features which were important from the 3GPP point of view. The first one was that 3GPP NRF feature, which is about keep alive, so that NRF can detect if any network function has gone down, and it can remove its profile from the database. There was one more feature, caching NRF results. Unfortunately, this couldn't make it to the final release, but it's going to be definitely there in the 1.3 release. It's there in the code, is there in the pull request, so people can just go ahead and use it if they want to. Then second feature what we have used is that 3GPP set feature. This is what makes it easy for multiple network functions to work together, and 3GPP does provide a way how to fall back to the other network functions if one of the network function goes down, right? So this one you can find extensive documentation in the 23.501 about how multiple instances can be handled by the consumer, how it is supposed to move to the new network, new instance if the previous instance has restarted. So we have used that feature to achieve multiple instance support. And to get these things, we have started using MongoDB in the cluster mode. Probably it was production setup, maybe using that, but now we have mandated it because we are using a couple of features in the MongoDB, something like MongoDB streaming, that's getting used to detect that some network functions is down or profile is deleted. Then we are using the timeout on the documentations on the Mongo documents. We are using multiple keys as a hashing key to get the quick lookup of the subscribers, right? So these are very high level things we have used to achieve the results. Let's see, like I'll just start to build it in a way that it helps everyone to understand what exactly we have done. So first thing, as I said, like we have added the NRF keep alive feature. So by default, we have kept this feature disabled, but you are encouraged to enable it. While we get more and more community feedback, we will enable this feature by default in the release 1.3. But currently there is one document page which is dedicated for this, about how you can enable various features of the 1.2 release. So what this feature means is that once any NF profile registers with the NRF, it's supposed to keep sending the updated profile to NRF based on 3GPP. And if NRF doesn't detect update coming from the network function, then it is going to detect the failure and it gets rid of that profile from the database, right? So this timeout we can configure in the configuration. By default, it's 60 seconds. NRF is able to handle these keep alive messages from the various NF. It deletes the profile if there is a timeout. And the next thing is that in the discovery result, now you get not just one network function, you will get multiple results which all the consumers have to handle. Right? That's the part we have done from the NRF side. If you look from the NF point of view, it's about the sending the keep alive at a periodic interval and handling the multiple network functions in the discovery result. We have done some changes in the Helm chart to make sure that if there is a graceful shutdown of any network function, then that network function can send the deregistration message. So that really helps into removing that instance from the database fast instead of waiting for the timeout, right? And the last bullet you can see on this slide, which talks about the NRF cache and NRF notification support. So we are very close to merge the code for the NRF cache. So which is going to be a model which can be used by any other network function. And NRF notification support is going to become important for us to optimize a lot of signaling when we go with the multiple instances. So we have a lot of groundwork done on the NRF notification. We are expecting that once this code comes, all the network functions will start subscribing for the notification and avoid these long delays while moving from one NF to other NF when there is any redundancy action. So this is about NRF keep alive. So let's see what we have done on the AMF side, right? So you can see that below there is like a traditional diagram where GNodeBs are connected to AMF, and then you have this SBI interface, and all the network functions are connected through that. So what challenge we have is that when we get with the multiple AMF instances, and if we just scale it as is, then what happens is that if you want to increase the handling of if you want to separate the connection handling versus the subscriber handling, that was a little bit difficult. So what we have done is that to start with, is that we have introduced this SCTP LB as one of the pod, which is single instance as of now, but can be run with the multiple instances. Only thing is that we have not tested with the multiple instances in this release. We have tested it only single instance. So what we do is that you can see that box AMF box gets changed to the SCTP-LB, then AMFs, number of AMFs, and then you have MongoDB, right? So GNodeB terminates the connection at the SCTP-LB, and then SCTP-LB handles this message to one of the AMF, right? So this is the new SCTP-LB is a new pod, which is again disabled by default, but it can be enabled. We have provided the configuration how it can be enabled. SCTP-LB to AMF communication is using the gRPC. SCTP discovers the AMF instances and it makes sure that it understands like how many instances are running in the system. One of the important thing which you can see in this point is that we have introduced this new model, which is the distributed resource sharing model. So when you have these multiple AMF instances coming in, the first challenge what we get is that how do we make sure that all the IDs assigned by AMF, they're unique and they are not colliding with the IDs assigned by other AMF, right? So that's where we have introduced this DRSA model, which makes sure that the IDs assigned to each AMF are unique. So IDs include like NGAP ID or maybe TIMC. So those IDs are going to be unique, okay? And last point is about HTTP-LB is disabled by default, and it can be enabled through Helm chart override values, right? So we have enough documentation in the Ethernet box. If you just search the HTTP-LB, you will just see the deploy equal to false by now as of today. You can just make it true to bring this configuration. And then you have to make sure that your GNOD points to HTTP-LB's service address and not the AMF address. So adding on more details about the what HTTP-LB is doing currently, that it tracks all the AMF instances in the deployment and it keeps the AMF pool ready. HTTP-LB reads the HTTP socket messages. As of today, the simplest approach what we have taken is that HTTP-LB doesn't decode any of the NGF messages. Okay, so it just takes the message and it just sends it to any one of the available AMF in the round robin fashion, basically, right? So naturally, if the subscriber is there with some other AMF, we end up in doing the redirect. So we have this redirect support, which involves the forwarding the message from one AMF to other AMF with the help of HTTP-LB, right? So that support is added. And if instance is detected to be down, if AMF instance is detected to be down, then we remove it from the AMF pool, right? So what we have, so this is just the foundation, and there are like few things which we want to do, which will happen in these upcoming releases, is that release the decode the NGF messages so that we can send it to the right AMF instance. So it's actually a trade-off whether you want to decode the message or whether you want to rely on the redirect message. So currently we have taken the simplest approach of the redirect message. Going forward, we will be adding the option of doing the decode NGF message so that at least some of the messages which are not encrypted and we can use NGF IDs to find out the MF instance, then directly send the message to the correct MF instance, right? And of course, we have to see like which one is a costly. Is it decoding is costly or redirect is costly? Multiple HTTP-LB support. As I said, like it should just work as of today as well. Only thing is we have not tested it, so that's the reason we don't advertise it that we're supporting it as of now. And the important factor or benefit what we will get with the multiple HTTP-LB support is that we will be able to support many more GNode bits so that each HTTP connections may, so the number of HTTP connections will get distributed across the HTTP-LB. And even if your HTTP-LB goes down, only the connected GNode bits to that HTTP-LB will see that HTTP connection going down. Rest of the system should continue to run as is. Right? And we wish to bring in the NRF API integration, like discovery and notification integration within the HTTP-LB to discover AMF instances. So that will optimize our signaling. And we will use HTTP-LB as a custom node, which is again given by 3GPP. So we can have the custom network function registering into the NRF and asking for notification service. Right? So this is going to be there in the upcoming releases. Now, okay, one thing which I have probably not mentioned till now is that while we have separated this HTTP-LB, we have started moving the subscriber states in the DB as well, MongoDB, right? So you can see that we do show that list of procedures which we have already added the MongoDB support. That means once the procedure is successful, we go ahead and update the subscribers in the database so that even if your AMF instance goes down, you still have the subscriber available in the DB. Even if you are even if you scale down the deployment, you will see that some other AMF will be able to pull the subscribers from the DB and continue to serve that subscriber, right? So we have some set of algorithm here, like you just read the subscriber from the DB if it is not found in memory. After successful run of the procedures, you go and update the subscribers in the DB. And of course, we delete the subscriber from the DB when one of these procedures like deregistration or network initiated deregistration procedure is executed, right? There are a lot of things to be done. There are a lot of error conditions to be handled. But as of today, we have tested all these things, whatever shown in this slide. And we are confident that this is good to get tested by all the community members and provide us the feedback. Right? We did realize that when we were doing this support, that it's very hard to test these features, and it's very hard to confirm that whatever you intend to do is really happening, right? So for that purpose, we have added few APIs, which is last two lines you can see on this slide, is that about purging the subscriber from the AMF instance. If you want to purge some subscribers, you have some REST API which can be used. And we have a REST API to fetch active UEs context from the DB, right? So these APIs are added to make life a little bit easy for the developers at least. And of course, we have other learning is that how to get all these metrics into the dashboard. So I'll come to one of that point, is that while we continue to add these instances, it becomes very difficult to get the metrics because user or operator really wants to know, given the subscriber, which AMF instance it belongs to, which SCTPLV is getting used, and what's the current state of the UE. Right, and so those things we have already metrics work in progress, and that will be available in next month or so in the master branch, and officially available in the release 1.3. So moving to the SMF changes. So the approach what SMF has is a little bit different. You can see that we have these multiple SMF exposing themselves on the SBI interface. But on the south side towards UPF, we have this UPF adapter as a new pod we have introduced. Right. So there are some reasons why we have done that. We will talk about those. So again, this enabling this UPF adapter, this is disabled by default, but it's easy to be enabled. You can go in the override values and you can say UPF adapter. Currently, it's marked as a deploy as false. You can mark it as a true. Okay. And UPF adapter, as it can be seen from this diagram, it's like it collects all the messages from the SMF instances and talks to actual UPF, right? So from UPF point of view, it's a single SMF instance running. And from the SMF code as such, they really don't know if they're talking to UPF adapter or UPF, right? So this middle layer really intercepts the message, modifies certain fields, and sends it further to UPF adapter. Okay. And at the same time, when response comes back, UPF adapter makes sure that it sends that response to the right SMF instance, right? And as a part of supporting these multiple SMF instances, we have started adding the states of these subscribers into DB. We have not shown DB here, but SMF also sends those subscribers to the DB, right? So all states are stored in DB. And one more thing to note is that currently the auto scaling is done manually. That means somebody has to run let's say you're running the 2 instances and you think that there has to be more instances to be added. You can run any Kubernetes command to scale up that from 2 to 3 or 4 or 5 based on whatever your need. The one of the thing which we are working on is that making some changes in the deployment files of the SMF and AMF to make this as an auto scaling without any manual intervention. And those auto scaling could be based on just CPU or memory or some custom metrics, right? So that's one of the things missing, but we have all the ingredient available to make these multiple SMF and multiple AMF work. So only thing is that instead of doing it manually, we want to do it automatically through Kubernetes horizontal scaler. So those things will come in soon, and we encourage if somebody wants to contribute that code, right? Or if not, it's going to be available in 1.3, much before 1.3 as such. So one thing is that we keep doing a lot of changes which are available in the master branches. If you want a stable run, you can always use the specific branch or specific tags to run your test. If you are fine with running the latest code, you can always go ahead with the master branches. So this is probably a summary of the SMF changes, what we have done. So we store all the PDU sessions in the database after every successful procedure. Just like AMF, SMF also keeps the subscribers in memory, and if subscriber is not found in memory, it goes and pulls the subscribers from the DB. It has the it multiple AMF, SMF instances. They discover the UPF adapter and send the message to that UPF adapter, and UPF adapter in turn sends the message to UPF. So one of the thing which we have not yet done is that how to introduce the multiple UPF adapter. So I know one of the important thing is that sometime it feels that we have made this multiple SMF or multiple AMF, but we have introduced the new single point of failure, probably a SCTP LB or UPF adapter, and that's the reason we want to make sure that in the upcoming releases we have these other endpoints like UPF adapter and SCTP LB also as a multiple instances, so that even they can go through the upgrade cycle or restart cycle if there is a need, right? So those things will come and they are in plan. We have just like AMF, NRF also, SMF also keep doing the keep alive, sending the periodic NRF registrations towards NRF network function. And we don't within the SMF we don't use the cache library as of now. So you might see a lot of NRF messaging happening as of today. So that's something we have definitely identified as one of the factor which may have impact on the call rate handling, right? So that's going to go away. Now, from the resource point of view, the unique IP address and unique ID assignment, it continues to SMF also use the same model, which is the RSM model. It's available in the OMEG project's util repository. There is one DRSM model, which is available to be used as a Go model for anyone. It's not tied up with the Ether project as such. It's very much independent, but it has dependency on the MongoDB, right? So, but you're feel free to upgrade the code to support any other database. Other thing which we have supported in this release from the SMF side is that we have the UE address allocation support from UPF, right? So till now, 4G was supporting UPF address, UPF allocating the UE address, but 5G was not supporting. So now we have added that support. So why that makes life a little bit easy while you have multiple SMF instances serving the same slice. You don't have to worry about how the UE IP address is going to get pool is going to get shared. Though we have this DRSM module handles the IP address sharing as well, but it's always good if UPF does the address allocation. That gives a lot of freedom to the operator in terms of giving different pools and in terms of distributing this address allocation complexity to the UPF instead of having all that thing in the SMF. And of course, DRSM model handles the instances going down and coming up. It detects that how many other peer network functions are running and what are their resources, and it helps into identifying the owner of any specific resource. And if some network function goes down, then they have inbuilt mechanism of claiming those resources since the one of the SMF or MF going away. So all those things are added in the DRSM. So things are very interface specific within the SMF. You can see that we have very basic interface APIs where like allocate the resource or release the resource, and all the complexity is part of DRSM. The one important thing is that while we have multiple SMF instances running, what happens if the subscriber which was associated with one of the SMF instance and that instance goes away, right? So of course that means that AMF is going to see some timeouts while AMF is trying to send some message to old SMF. It's going to see some timeout, and then it uses the a way to send the message to any other SMF within the same set. So this again goes back to the 3GPP feature. So all the SMF instances currently running in the single set. So AMF can just go on any other SMF and just get the subscriber signaling through, right? This currently we might see some delay in terms of sending, detecting the failure and moving to the next SMF. And of course, NRF notification is going to help us into reducing that time delays. Okay, after the pod restart events. So this again makes NRF notification a very important feature for us while we do these multiple instances support. The fourth feature or fourth bigger area which we have done is that while we were developing these multiple AMF and SMF instances, it was hard for the developer to make sure that whatever they are doing is really working, right? So we needed a tool which can give us a lot more control in terms of executing the procedures in a way where developer can execute all the flows, right? So you can see on the right hand side, this image, it talks about the custom profiles. So that's something newly introduced in the Gnode vSIM now. So for those who are not aware what's a Gnode vSIM, it's like something which supports a Gnode V plus UE simulation to test the 5G core networks. So we have extensive document about Gnode vSIM on the SD Core website. It has all the basic features about the profiles like registration or PDU session establishment, and then deregistration procedure, then UE initiated deregistration, UE initiated PDU release, and network initiated deregistration, network initiated PDU session release. So there are like roughly 6 to 7 procedures are currently supported. And we are in the phase of adding the new procedures, right? So coming back to custom profiles, you can see on the right hand side here, the last block is about the iterations. So this is what is very unique. In the previous Gnode vSIM code before the changes, it was like a fixed profiles where once you run the Gnode vSIM, it goes to that profile, it executes those set of procedures for each profile, and you get the result whether things are passed or failed. But what we have done in the custom profile is that you can see you can write these iterations, like I want this iteration 1, which goes through these procedures. Then after iteration 1 is done, I want to go to iteration 2, and I want to repeat this iteration 2 for 5 times in this, at least in this example. Okay. And then once this 5 times iteration 2 is done, then you go for the iteration 3, and then it says, okay, deregister the subscriber, right? So you can have any number of iterations like this. So this really gives a lot more freedom for you to execute the procedures. And with the multiple instances, we had a requirement of adding the delay between the procedures, so that this last number indicates like after 5 seconds, after registration is complete, wait for 5 seconds and go for the next procedure, then wait for 5 seconds, go for the next procedure, wait for 10 seconds, and then follow this iteration, next iteration, right? So it looks easy, but we have added some more things here, is that to give more control, apart from the just delay, you can see there is like step trigger. That means that one procedure is executed and the Gnode vSIM wait for the user input or API call to go and execute next step. So it goes one by one step. So you can see that I execute one step, and then I have subscribers in the AMF, SMF. Now I get the option of restarting those AMF or SMF, and then going back onto the Gnode vSIM and calling the API to make sure that next step is executed. And then we realize that, okay, now AMF is the one which is already restarted. It has received new message and it doesn't know the subscriber is not in the memory. Then it goes into the DB, right? It becomes very easy for the developer to make sure that whatever he's doing is right. And so that's the step trigger. Then, as I said, we have delays between the procedure. We have this execute in parallel, which is like all the subscribers in this profile. In this case, it's like 5 subscribers in this profile. You can execute them in parallel. So that's like, we have tried it for 100 plus calls with a single instance. That means you can have 100 plus UIs sending the parallel registration messages, or all depends on whatever the procedure. So in this case, my procedure is this one. So all the users you can run in parallel. So it gives a lot more confidence in terms of what we are doing, right? And we can test things thoroughly. Then this is what example of the existing old profiles. Here as well, you can, so as I mentioned, this procedure list is fixed. So if we say the profile is registered, so we know that what are the messages we are going to exchange. So user cannot change anything. So these are the fixed profiles. but you are encouraged to create these custom profiles. As long as these base procedures are supported in the GNODB SIM, you can create any of these procedures as per your need. You may try to do registration multiple times, or AN release multiple times, or service request multiple times in whatever order. So as long as it's a 3GPP order or baseline code has the right states, you can execute those procedures, right? So same way in the default profiles as well, you have the option of executing the subscribers in parallel. I think I have not shown that as a configuration here, but yeah, you can execute subscribers in parallel. 100+ subscribers we have tried. I'm sure it will go to even thousands. So that shouldn't be a problem. You can enable the step profile. There is a link given here which calls that API to send the message to GNODB SIM so that it can go and trigger the new step, or tell the GNODB SIM to go and execute the next step, right? Delay between the procedures cannot be provided in these profiles. It's by default, I guess we have 1 second delay between the procedures. So you can add the new calls in the existing profile. If let's say I'm running some profile with the step trigger true, then and on the fly I want to add some extra subscribers, because I don't see, you can see here that 5 subscribers we are adding starting this profile, but later we realize that what happens if I add some more subscribers, right? You have option of calling these APIs. So these are just REST APIs, and example is given in the scripts. You are free to build your own scripts to call the APIs. So you can say that I want to execute 10 more calls in this current profile, right? So that's possible. Then apart from this thing, there is a REST API to trigger the new profile creation as altogether. So you are running GNODB SIM and you want to create a new profile on the fly. So you can call that call the API. Example is given in this profile execution, which is part of GNODB SIM code. But you can, again, as I said, you can create your own profile as long as it fits in this grammar. We are good, and you can generate or start new profiles, right? So few things like some of our community members realized that DNN and slice information is not really configurable, even if it is shown here. So they contributed to fix that code. Right? So we have a lot more things which is upcoming. The first important thing is like supporting the GNODB handles. The code exists underlying. It's a matter of just using existing APIs to support the underlying handles. You can already support multiple GNODBs in the current GNODB SIM. Just that handle profile we have not yet added. Then there was one request from community members to just run the GNODB SIM as a standalone container so that it can be used to test any other 5G core and not just the SD core, right? So that's also something going to happen. And then few things like supporting error indication messages or GTPU echo handling and negative testing, external interface to send uplink traffic. So currently GNODB SIM generates its own internal packets to make sure that data path is fine. But that's not something suitable if you want to feed external data traffic, right? So we are working on that, adding interfaces for sending the traffic. We have done a lot of improvements thanks to all the community members who continuously gave us the feedback about few of the documents, like documents were not correct or they were not covering all the aspects of the deployment. Many community member tried with the different operating system or different version of the operating system or different way of, so we have given one set of steps, but people have tried different steps and they realized that we have some issues in the documents, right? So some of the community member contributed directly to document. Some of the members, they had given enough details on the Slack, so which helped us into improving the document. So we did figure out, so I have provided all these links here, like the currently a lot of issues we have seen with the UPF deployment. There's a lot of, there's a lot of understanding involved when you are deploying the UPF, and we have documented some of the things in the UPF, but it has some of the private repositories in picture, and that's making life a little bit difficult for the community members. So we have improved it, but it's still not up to mark. So we will be working on that. Then I have added like example on the QoS configuration, then application filtering rule, and Default Ether in a box has now comments which will help you understand what is the significance of those values and how it's going to impact the SD code deployment, right? Recently, we added the design section to capture the new aspect of the features. But at the same time, if you visit our Google Doc website, we have one public Google Doc folder which captures some of the design documents in detail. So you are encouraged to go on the document website, and from there you will get the Google public folder link where you should have the access to view, and most likely I believe you should have access to comment as well. If you need access, just go ahead and ask for access for comment or edit based on your profile. Will provide you the access. So what is it that we are working on currently, right? So there is one new section added in the document which talks about the 1.1 release, 1.2, and then there's a new thing which talks about the upcoming releases, right? So where we have captured the focus of our team or the community. So I have tried to list out the few things here again, which is like improving the UPF deployment. This is the one of the area where we have got a lot of comments from the community member that they face a lot of problems. And we have helped many individuals, but we have failed to add those contents on the website, right? So we just want to make sure that UPF document gets updated, and old references which are not really publicly accessible, we remove them, right? That's one of the goal which will happen in coming month only. We will not be waiting for 1.3 release. Then, as I mentioned, like supporting multiple metrics from the NFs and creating dashboards. So one of the missing thing as of today for those who have used Ether in a box is that we don't have the target to create the dashboard for 5G, right? So we will be making that available in the coming months, and it will be officially part of 1.3 release. And while we are working on the AMF and SMF cloud native, we have some of the proposals how we can make the cloud native UPF. The purpose here is that adding more UPF instances, if there is a need for more throughput, or if there is a need for adding more subscribers in the same slice. Right? We did talk about what are the GNodeB features we are going to do. Then there's a spin up and down of the NF instances based on the metrics such as the CPU or memory or custom metrics, right? So this is something which will be definitely available in the 1.3 and maybe much before that, because we have already started working on it. NRF notification support. This is to improve the signaling within the SD core, and to reduce or minimize the latency when there are redundancy events, right? So NRF cache and NRF notification is going to help us into doing that. So our community members are working on this currently. And the next two topics are multiple SCTPLB and multiple UPF adapters. That's about making sure that we don't have any single point of failure, right? We have this, you can see UPF initiated message handling. This is something area which should we have not paid attention, though currently it is supported about the session reporting. We have to make sure that with UPF adapter that thing continues to work, right? So we may have some changes not done as of now, but they will be available in 1.3. We plan to give this release somewhere around the January 2023, and the code development is going to get done in the December. So we'll have 1 month to do the testing and releasing it to community, right? I want to invite everyone to contribute, and there are multiple ways you can contribute. You can send us queries which helps us into understanding the problems, and which also helps us into knowing the documentation issues, right? So even if you send queries, that is also a contribution for us. If you think there is some value add features for the private 5G or any small operator deployment, just go ahead and send us what feature you are looking for. If you send us the proposal which brings in more details, then that's good for us. Then if you are just a Ether user, just go ahead and let us know your feedback and where we can do improvement. If you raise the code review request, we are happy to accept your code review request. Then as a developer, please go ahead and raise the pull request for the code changes. If you are someone who is from the quality assurance team, QA team, and just want to try out some of your testing skills, just go ahead and use it, right? So there is everything. There is like each profile or each persona can do some of the other help for our community. So we really encourage to do that. So one thing recently we have started, which is not just about SD Core, but it's about Aether, is that there's a community calls which we conduct once a month as of now, where you will be able to participate and you will be able to see how other members are using Aether, right? So tomorrow, day after tomorrow, we have one more community call where Kajit is using the Aether, and they are going to present how they're using Aether and what are the probably challenges they have seen. And maybe you will see the feedback from the real user in the live meeting, right? So you are encouraged to register for that meeting and see how they have commercialized Ether code to give the private 5G solution, right? And the previous meeting recordings are also available here. So these slides and recording will be made available to you. You will see email from our marketing team, which will have all the details, right? So that's all I had. I can probably go through the questions to see uh, and I'll try to answer them. So first question I do see from the Ram Kumar about, is SD core same as OAI core? So answer is like no, SD core is not OAI core. So SD core has two components, 4G and 5G. 4G was initially seeded. Some of the components came from the Infosys and Intel and even Sprint. Many more companies had contributed to the 4G development. In terms of 5G, we have forked from free 5GC probably around 2 years back. And we have one section in the document which talks about what are the changes we have done on top of free 5GC, right? You are encouraged to see that. So that will tell us like what are the various things we have fixed or what are the various APIs we have added, right? So and then UPF is something which came from Intel initially, and now it is mostly managed by the many more community members. And our UPF is common for both 4G as well as 5G, and we are not using UPF from any other, not even from free 5GC. So it's initially coming from Intel. Yeah. And there are two, as I said, there are two versions of two types of UPF available within the SD core. One is a base UPF, which is a software version of UPF, and one is a P4 UPF, which is like P4 language based UPF. So yeah. Okay, now next question I see that is from Rajak. When is the next upcoming release? So I think, yeah, I already answered this question. So we are expecting a code complete as a mid-December, and the code is going to be available for all community by mid of January. That too, if you're waiting for official release. I mean, if you're fine with using the code from the master branch, you will start seeing those commits coming in this month as well as next month and December. So we will continuously keep on adding the code in the master branch. So that's available. Only thing is it's something which is probably not tested or tested minimally. So yeah, go ahead and use those features, and you can probably keep track of our repositories. Just enable the notification or watch on our repositories, especially AMF, SMF, NRF, and UPF. These are the 4 repositories going to see a lot of changes in the upcoming months. So set up the notification and you will get to know what are the changes we are doing there. Again, one more question from Rajak, which is, in the current release, does multiple instances of UPF is supported? As I told this about this question, like we are working on the multiple UPF in this quarter. That means it's going to be part of 1 or 3 release. There are some challenges about how to make UPF cloud native or multiple instances because of the various networking aspects involved in the UPF. But we have identified the way how we can do that. And that first version of cloud native UPF or multiple instances of UPF is going to be available in the 1.3 release. Then next question is from Jay Prakash. Is lawful interception and URLLC in the roadmap? So I think this LI and URLLC. So I'll just talk about LI first. So LI feature request has come in the past from multiple teams, but we don't have any support as of now. So given that we are still working on the features which are important for the private 5G point of view, we have not given focus on the LI. So no, so at least I don't see LI coming in for the next 5 to 6 months, at least nothing from the existing community members. If somebody is bringing in the LI and helps us improve SD core, we are happy to receive that contribution. About URLLC, so if you see, like, there are like two parts, like multiple parts around this URLLC. It requires the support from the UPF, as well as it requires support from the GNodeBees. So we have had big challenges in the getting GNodeBees, and that's the reason we still don't have the right use case where we can demonstrate this URLLC. Right. So yes, but I'll say that we will be definitely bringing in the use case which we can demo with our SD core, and URLLC you will see coming in few months, not in the 1.3, but some aspect of that will start coming in the 2023. So URLLC is there in the roadmap, definitely. LI, no, as of now. I see question from Ram Kumar talking about, are you running Valgrind or any other code quality check tool? Also any security tool like Black Duck and SBOM is run. So we have some of the tests we run through the GitHub action, but not for all the repositories. Again, there are like there's a lot of work and the code base is very huge, right? So we rely heavily on the community members to help us on this side. So if somebody is expert on integrating these kinds of aspect using either GitHub Actions or Jenkins, please come forward and help us. So we do have these things in the plan. We are doing it slowly on the repositories, but it's not there for all the repositories in the SD core, right? So answer is like, yes, we wish to do that. We are doing it, but we don't have the manpower to complete this for all the repositories, right? So contributions are probably welcome in that area. Will it have, so next question is coming from Henrik. Will it have dashboard available for 4G as well? Additionally, will it available for both AIB and other types of deployment? Yeah, so currently 4G does have the metrics dashboard, and currently whatever code we are changing, it's for 5G. But I'm sure we can do extend the metrics architecture for 4G as well. But 5G will have a lot more metrics available, and we will make a dashboard which will be available in the AIB, and by default metrics will be available in the Prometheus, and you are free to create your own dashboards. If you have enough skill sets, yeah, you can go ahead and create the dashboard. Just wait for a month or so, and then watch for the website metric function. You can see it on the OMEC under OMEC project metric function. Just put a watch on that repository, and you will see that some changes coming in this month or maybe mid of November. And if you are ready, you can try out those beta features and let us know feedback. Next question is, how many unique APNs can be created in release 1.2? Yeah, so we have not tried, Jay Prakash. We have not tried how many APNs we can create, but at the same time, we have not put any limit. But what I can see is that as long as if you're talking about 1.2, and if you're talking about the 5G core, then 5G core in 1.2 was just single instance of SMM. So if you create a lot more APNs, then there's a lot more work SMF has to do in terms of IP pool management, right? So it may still work with the 2-digit APNs, but your performance may go down drastically. But if you are not worried about the control plane performance, yeah, I mean, you can go even in the 2 digits, like maybe 10 plus or 20 plus, and probably let us know. We have not really tried this benchmark test on the number of APNs. We encourage community members to try these parameters and let us know how their test went. Handor is supported. Next question is from Jay Prakash. Yeah, Handor is supported. Only thing is, when I was talking about Handor with in the Genode SIM tool, right? So we do have the commercially available tool, which is available to ONF from NG40. It's one of the commercial vendor for the tools. They have extended their free license for the ONF, and which is integrated in the CI/CD. So we do use NG40 tool to do our tests. So core does support it, but we don't have that support in the latest Genode SIM, and that's where I was referring that we will be having that support in the tool, which is very much developer friendly, available in this upcoming release. What's the maximum download and upload latency achieved in the field trial and lab scenarios? So this question really depends on what kind of deployment you are doing. So many of the people, what I have seen is that they end up in using the A packet mode of the UPF, which is little bit not, which doesn't give performance like a DPDK mode, right? So people have tried it with the UDP and TCP level performance. I have one shared document. You can go ahead and look at the UPF repository and see the latest issues there, where some of the people have reported their numbers, and some of the companies, they have reported that they are facing some TCP issues, performance issues. So you will find some numbers there, but I'll say that it really depends on what kind of hardware you're using and what kind of mode you are using for the UPF deployment, right? So Ram Kumar does say that he will help with Valgrind, already running it for Open5gs. Yeah, I will really appreciate, Ram. Thank you, and just go ahead and do it for one of the repository and let us know. I do remember there, like, you should check the Valgrind. You should check the Helm chart as well. We do have some support, but just go ahead and verify it, and if something is missing, add on. Thank you. Amit A says that there are some mentions of Ether SD core supported on the GCP Anthos. Any plans to share docs on it? Yeah, I think this is the exact area where I think Anthos and GCP, we have one document on the Anthos. I'll have to check with the internal team, and if possible, I can just put it on the public folder. I don't think there is anything sensitive which we cannot share it. We will definitely share how and what we did on the Anthos. And the GCP, yeah, probably I can add a couple of lines within the Ether doc about how we are running it in the Ether production, how we are using GCP. So we may not be able to give you each and every templates of the GCP used to deploy the VMs or bare metal, but we will be able to give what are the things we have done. And that's one of the area we could not open it up for the community about giving all the details, because it was not possible to share those documents as is. But we'll filter that and we'll make that info available. Yeah, I think we are right on the top of the hour, and I have mostly answered all the question. I think okay, there is last question. Would it be possible to share the UPF performance number, whatever available in the SD code docs? So Amit, I'll encourage you to just see the UPF repository and latest issues. There is one I have opened, and there is like a document created on that, and the document link, Google Doc link, is also shared there. So you are encouraged to see that. So some of the people have reported like good numbers, some of the people have reported bad numbers, and we are debugging on like why there is a difference between these performance numbers, right? And probably, yeah, I mean, we encourage really that community driving most of the decision, most of these kind of points, because they have more resources compared to ONF, right? So you are encouraged to add the comments and ask for the people to give their performance number there, but there are 3 to 4 community members actively testing the performance. Right? So we don't have the NEF or analytic function as of now. So once we come out of this existing cloud native efforts, we will bring in this NEF. NEF seems to be something definitely possible, because that's something is exciting to have it as a portfolio within the SD core. Yeah, I think I have answered most of the questions, and okay, I think I should have done the stop sharing.
Okay, no problem. So if anyone has any additional questions, please feel free to use the ONF Slack to ask those questions. And the community is very active in responding to those. And to remind you, this session was recorded, and we will make the recording available along with the slides. And thank you, AJ, for sharing your insights and your knowledge about SD Core. And thank you to everyone for joining us.